on eccentric loaded riveted joint. So you have this bracket here, this diagram here, where you have the force P acting at the distance of E eccentricity away from the CG. So if P is acting on this dashed line here, the red dashed line, okay, then we cannot consider eccentric loaded riveted joint. So the P must be away from the center of gravity. Distance E, eccentricity. So solving problems on eccentric loaded riveted joint. Okay, so what you need to do is rivets here 1, 2, 3, and 4. There are 4 rivets here 1, 2, 3, and 4. So you have to label it as 1, 2, 3, 4 in clockwise direction or in anti-clockwise direction, up to you. Okay, so when you take P times E, you should have a turning about the CG point here. Okay, when you take P times E, you should have a turning moment about the center of gravity, this form. Okay, so what you need to do is, okay, you have to go according to the steps here. Step 1, find out all the cross-sectional area of the rivets 1, 2, 3, and 4. Now all the rivets, they are of same sizes, that means same diameter. Okay, then first thing you have to do is on the system here, what you have to do is you have to draw a horizontal line going through the rivet 3 and 4, going through the CG of the CG of the rivet 3 and 4, and that should be your x-axis. And then consider your y-axis, a vertical line that is going across, going through, okay, rivet 1 and 4, going through the CG of rivet 1 and 4. Okay, and then you have to put a CG here for the whole rivets. For the riveted system, you have to estimate roughly. Initially, you have to estimate the CG point here. So the distance between this x-axis to the CG, that should be your y bar. This distance here should be your y bar. Okay, and then from this reference axis y, okay, to the CG point, that should be your x bar. So your x bar should be here, and then your y bar should be here. Okay, so those are the coordinates of your center of gravity. Those are the coordinates of center of gravity. So that is your first step. Then you have to know the distance of x1, x2, x3, and x4, and also the distance of y1, y2, and y3, and y4. So how you measure x1, x2, x3, x4, y1, y2, y3, and y4? So from the reference axis x, okay, so you measure the vertical distance from axis x to rivet 1. So from here to rivet 1 is your y1. Then from the axis here to the center of rivet 2, this should be your y2. Okay, so y3 and y4 should be 0. So this is y1, this is y2, y3, y4 should be 0. Then when you measure x from the reference axis y to the center of rivet 2, that should be your x2. And then from the reference axis y to the center of your rivet 3, this distance here should be your x3. Okay, x1 and x4 should be 0. So that is your step 1. Get the diagram drawn. Okay, label the rivets. Make sure you have the applied force and the eccentricity. Put the center of gravity initial estimation of where the G should be. Then put on your reference axis. Okay, draw your reference axis of x and y. X should be going through the rivets of 3 and 4, and y should be going through the rivet of 1 and 4. Okay, then you apply the formula. Then you apply the formula for this. riveted system here that we call the first moment of area. Now, moment of area means the area multiplied by the distance from the center of the section to the reference axis. So if let's say I want to find the coordinate of the center of gravity G, okay, if I want to find the coordinates, those coordinates for the center of gravity of G, then I must have X bar and Y bar. So X bar applying first moment of area, okay? So you have A1, that is area, the cross-sectional area of rivet 1, multiplied by X1. X should be in this distance here from the Y-axis. So X1 should be 0, and then A2, the area, the cross-sectional area of rivet 2, with the distance X2 that is from the reference axis Y to the center of rivet 2. This should be X2. And then A3, X3, A4, X4, and so on. Now this A here means the total area. Total area means A1 plus A2 plus A3 plus A4 for this area. Then the next coordinate, okay, that is the Y bar. So you have A1 Y1 plus A2 Y2 plus A3 Y3 and plus A4 Y4. In this case, you have only 4 rivets. So A1, A2, A3, and A4 are the respective cross-sectional area of the rivets. Y1, Y2, Y3, and Y4, those are the distance that you measure, vertical distance that you measure from your x-axis. That means from your reference axis X. So vertical distance, the vertical distance that is Y. So Y2, and this distance will give you Y1, where Y3 and Y4 should be 0. This is the first step you must do, finding out the coordinates of the center of gravity, X bar and Y bar. Now this riveted system here, these rivets here, they are arranged in this manner and it is symmetrical. So if it is symmetrical, we actually don't need to apply first moment of area in finding out X bar and Y bar. Symmetrical here like this. Okay, so X bar, you can straight away just take this distance here. Oh, sorry, this distance here, X bar. And then Y bar, just this distance straight away. Okay, so which you don't have to apply the first moment of area method if the rivets are symmetrical like that. Okay, that is step 1. Step 2, introduce forces. Okay, P1 and P2. Okay, now this one actually you can skip. You just, what you need to do is you draw on rivets here, you draw a line of force. Okay, line of action of force that is acting vertically downwards on each rivet. Okay, assuming that all the rivets are of the same size, the effect of P1 equals to P. Okay, so P1, P2, P3, and P4 is actually equals to P, this total load, divided by N, the number of rivets. So if let's say, for example, you have 40 kilonewton here, 40 kilonewton. So your P1, which is acting vertically downwards. So on this diagram, you actually have to draw an arrow acting vertically downwards from the center rivet 1. From center rivet 2, also you must draw an arrow acting vertically downwards from the center of rivet 2. And then from center of rivet 3, the same thing. You must draw a vertical arrow, okay, acting downwards because this is acting downwards. So all the arrows, vertical arrows from the center of each rivet must be acting vertically downwards with the arrow pointing downwards. And then you can label all the forces P1, okay, P2, P3, and P4. That means you must draw arrows from the center 1, center of rivet 2, center of rivet 3, from the center of rivet 4. Draw arrows which are acting vertically downwards. Okay, represents P1, P2, P3, and P4. So the magnitude of P1, P2, P3, and P4 should be this total load here divided by 4 rivets here. Because in this case, you have 4 rivets, so you divide this by 4. So each force here okay, acting at each rivet vertically downwards should be 10 kilonewton, 10 kilonewton, 10 kilonewton, and 10 kilonewton if this is faulty. Okay, that's step 3. On the diagram, you must draw those vertical arrows like this. So you have P1, P2, P3. Now this is written here all as subscript S, yeah? So it should be P1, P2, P3, and P4. So on each rivet here, draw vertical arrow downwards, downwards, because this is downwards. So downward, 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 label it as P1, label this as P2, label this as P3, and label this as P4. Okay, so if this is faulty, then each of them will be taking 10 kilonewton. Sorry. Okay, so we don't go to this diagram first. Now, step 4, to find the primary forces, that is this P1, P2, P3, and P4. So this is the total load that you have 40 just now. This n here is the number of rivet 4. So 40 over 4. So P1, P2, P3, P4 must have a 10 kilonewton force. So indicate each primary shear load on each rivet as P1, P2, P3, and P4. Then step 5, to find the secondary shear load, the following two conditions must be adopted. To find the secondary shear load, you have primary shear load. Primary shear load that is causing, what is primary shear load? So when you refer to this arrangement here, actually you've got two failures that might occur, two possible failures that might occur. So the rivets might fail when this plate here, gray color or blue color plate here, slide downwards due to the P. So when it slides downwards, so that is why we consider P1, P2, P3, and P4. So those are considered primary shear load. Now the secondary shear load is when the P times the E, which creates a turning about the center of gravity. So the rivet 1, rivet 2, rivet 3, and rivet 4 will be all shear off when this blue plate here turn about the G point. When the blue plate here turn about the G point. So all the rivets will be sheared when it turns. That is called secondary shear. Primary shear is when this plate here slide vertically downwards. So that is why you have P1, P2, P3, and P4. Secondary shear load, you will have F1, F2, F3, and F4. Or you can name it as S1, S2, S3, and S4. So you can see here, these are all secondary shear loads. Now, how do we consider the secondary shear loads? F1, F2, now remember P1, P2, P3, and P4, they are called primary shear loads. That is when, if the rivets fell under direct shear, that means when the plate slide vertically downwards. So P1, P2, P3, P4. Now, secondary is when the whole thing turns about the CG point. That means when P times E it turns. So therefore, that is why you have to consider secondary shear load as F. We use the symbol F. Now, how to locate the secondary shear loads here on the diagram? Now we have got this, okay, P1, P2, P3, and P4. Now, what you need to do is you need to draw lines from the center rivet 1 to the CG. Line from the center of rivet 2 to the CG. Line from the center of rivet 3 to the CG. Line from the rivet 4, center of rivet 4 to the CG. That is why you have L1, L2, L3, and L4. Okay? Then once you have got L1, L2, L3, and L4, your secondary shear load, okay, will act in this direction, okay? That is, when you look at it, is in clockwise direction. It's in clockwise direction. Now, why the secondary shear loads, they are acting like this? That is because it's due to P times E. P, you see the arrow is acting downwards. So above the CG point with the P force, with the length E is actually giving you a turning in clockwise direction. So that is why when you look at F1, F2, F3, and F4, seems like they are going in the clockwise direction. Okay, clockwise. So you got F1, F2, F3, and F4. And make sure these arrows here, F1, F2, F3, and F4, they are 90 degree to this L1, L2, L3, and L4. 90 degree. That means these L's here, the lengths L's here, they are called radial lengths. L1, L2, L3, and L4. So these force F1, F2, F3, and F4 have to be 90 degree to these radial lengths. And it is denoted as 1 for rivet 1, 2 for rivet 2, 3 for rivet 3, 4 for the rivet number 4. And all these are in clockwise direction. So you can see F1 times L1, F2 times L2, F3 times L3, and F4 times L4. They're actually providing us a clockwise direction of rotation, and this causes the rivets to fail secondary. Okay, that means the second way of fail. That means the second possibility that the rivet fail. Okay, so once you have got your secondary shear loads, okay, then from this, okay, you draw, okay, parallelograms based on the P and the F, based on the P and the F, based on the P and the F, based on the P and the F. You have to draw parallelograms like this on the diagram. Parallelograms. Okay, so the diagonal line of the parallelogram shows you the resultant force due to the P and the F on each rivet. Okay, step 5, to find the secondary shear load, the following two conditions must be adopted. 1, the secondary shear load is proportional to the radial distance of the rivet under the consideration of the center of gravity. Now, what does that mean, this part here? It means that the longer this length, the greater this force. Okay, the longer this length is away from the CG, the greater will be this force. The shorter this length, then the smaller this force. Okay. The secondary shear load is proportional to the radial distance of the rivet under consideration, that means 1, 2, 3, or 4, from the center of gravity, that is G, of the riveted system. That is part A. B, that means when you consider secondary shear load, you must fulfill one condition, second condition. The direction of secondary shear load is perpendicular to the line, perpendicular, that means 90 degree, to the line joining the center of the rivet to the center of gravity. So see this, the F here must be 90 degrees to these lines. So these are the two conditions. Make sure you fulfill these two conditions. Okay, so F1, F2, F3, and F4, they are the secondary shear loads. L1, L2, L3, L4 are the radial lengths. So, and we know that from the first condition that we have, F is proportional to L. F is proportional to L. So you can say F1 is proportional to L1, F2 is proportional to L2, F3 is proportional to L3, and F4 is proportional to L4. Step 6, total moment about the center of gravity. Total moment about the center of gravity. Go on. So you can see the total moment about the CG. So first thing is previously from the previous line, we have this. F is proportional to L. F1 is proportional to L1 and so on. Then you can write F1 over L1 from that proportional symbol can be equals to a constant. And F2 over L2 also equals to a constant. F3 over L3 also equals to a constant. So constants are the same. So therefore, you can equate F1 over L1 to F2 over L2 and to F3 over L3 and also to F4 over L4. So, and then you can take the relationship between F1, F2, F1, L1, and F2, L2, and also the relationship between F1 over L1 with F3 over L3, and also the relationship between F1 over L1 with F4 over L4. And taking F2, F3, and F4 to be the subjects, so you have all these equations here and include F4, which is equal to F1 over L1 times L4. You can see all is based on F1, L1. The only thing is L2, L3, and L4 when you take F2, F3, and F4 to be the subject. So now, based on this diagram here, okay, the P times the E will give you a turning about the CG here. So this turning here is actually equals to the sum of all these forces times length, secondary shear forces times length, secondary shear forces times length. So this P times E can be equals to the sum of F1 times L1 plus F2 times L2 plus F3 times L3 and plus F4 times L4. So you've got this equation here. So once you've got this equation, what you need to do is substitute F2 here, substitute F3 here, which is equals to this, substitute F2, which is equals to this for F2, substitute F3, that is this, F3 for this into here, then and F4 as well. Okay, so you'll get the whole equations in terms of F1. Then from there, you can find out F1. Okay. Once you have found out F1, put it back into this formula to find out F2, F3, and F4. So once you've got P1, P1, F1, P2, F2, P3, F3, P4, and F4, then you can calculate the resultant. So you get resultant R1 based on F1 square plus P2 square plus 2 times P2 times F2 cos theta. So the angle theta is taken based on, okay, the diagonal line that which you have drawn and with your resultant, the angle, okay, the angle to be calculated as well. Okay, so from there you have to choose between R1 to R4, which one is the greatest, which one is the maximum to design the diameter of the rivets. Okay, hope you understand. And that's for this part, okay, for this section. Now the next part here, we will be doing examples, okay. We have few examples to go. Thank you very much.